Okay, this is from 1.5b transformations. We have some single transformations to perform here that I'm going to just go over a couple of these that may have caused a little confusion for you, or you weren't sure how to start. So just some comprehensive review through the homeworks on these videos. This is just a random curve here that we're looking at. It happens to be a circle, but a lot of times you don't have anything in particular. You may be just given a point to work from, but here we have several points that we could figure out from this shape here. So I just kind of marked down the key points that I'm gonna use to help me draw the transformation. I'm going to look at C here and compress horizontally by a factor of a half. Now just please note that that means that we're going to multiply all the x's by 1/2. If we had this in algebraic form, it would look like f of 2x, where b equals 2. Therefore we would horizontal compress by 1 over b, which is 1/2. We always do the inverse thing when we're looking at the input and how we transform. So if I look at these points here, I have 1, 3. So I just wrote that over here. I have 3, 1. I have 3, 5. So we jot those down over here, and 5, 3. Now you are very welcome to just work right from the graph itself and perform your transformations, but sometimes it's just helpful to list it out and go from there and just do it more algebraically. So we would have 1/2, 3 halves, 3 halves, and 5 halves. So now I'm going to plot the new point. So 1/2, 3 would go there. And then I would have 3 halves, which is 1.5, 1. Making them into decimals or mixed numbers, especially if they're kind of awkward fractions that you're not familiar with, but these are pretty fine. And then I have 1.5, 5. So we got to go up here. And then I have 2.5, 3. So these dots, so the pink dot, for instance, on all of these, got multiplied by 1/2, any of the x, so it got compressed by 1/2. So it's kind of squishing up horizontally. Okay, and then you can just connect. Doesn't have to be perfect. I'm going to get rid of those pink dots. You can see how that works. So this would be C. Okay, so sometimes we have more than one thing to do at a time. So we always want to stretch or compress before we shift. So that's why these are all just single unrelated ones, because they would be in the wrong order. So I will do another one down here where you can see for number 2. If you have any other questions on any of these and you want me to do more of them, let me know. I'll post some solutions up, but I don't want to use all the video time to do that. So for number 2, we are looking at more combinations here. So let's do let's do this one here. We'll do C again. So my vertical, this tells me y equals 1/3 g of x minus 3. So this is not an equation. This isn't like suddenly a linear equation. Sometimes people want to make this be y equals 1/3 x minus 3, but that's not what that is. Okay, so I want to be clear. This is representing the transformations that I would perform on some random curve y. I happen to have given you the y right here, and we can pick some points to work from. So you have to have some information about the curve. Either even just one point. I asked you in number 4, a lot of times just tell me where this one point is going to end up after these transformations. So here, let's look at, this tells me I have a vertical compress by 1/3. I have also a horizontal shift, and it actually is the opposite than what it says here. So if it says -3, it's actually +3 is B, because it's always the opposite of, not B, but the 3. And then I'm going to go right 3 units, okay? So to show that here, again, I might want to just jot down some of the original points to help me out. I do want you to get in the habit of doing any compressing or stretching before you shift, because that's like multiplying before you would add or subtract. So, but because one is vertical and one's horizontal, it really doesn't matter in this case, but just so you get in the habit of always thinking of multiplying first. Reflect could either go at the very beginning or the end. I like to do it at the very beginning, because that's kind of like, just multiplying by -1. So you can a lot of times do it in conjunction with your stretch or compress. So the points that I'm looking at are, I have -6, 0, because I can get the shape well enough as long as I can get a few key points. So then I have 0, -6, and I have 3, -3, and I have 6, -3. Now I like to work off the points that I've written down here rather than trying to look at the graph and perform the transformations simultaneously. But you may have your own preference, and it's really fine how you do it. You just really should, for work, you should give me like this information here, show me, and in stages maybe, show me something other than just, copying the key. So here we have my vertical compress would be multiply all these y's by 1/3. I'm going to go ahead and do that. I'm going to pause the video. You can do it along with me. And then on the other side, I'm going to do the x's. I'm just going to add 3. So I'm adding 3 here, multiplying by 1/3 here. So for the y's, when I vertically compress and it's just a 1/3 there, that is just verbatim. That's how, it just is going to be done out. The vertical, the output is just exactly as it reads. Where they input anything inside the parentheses, that's where, when we transform, we're doing the inverse operation as it looks, okay? Okay, so I've figured out my points. I added 3 to each of these x values, and I multiplied all my y's by 1/3. So now I just have points I'm working from, and I plotted them: -3, 0. I have 3, -2, 6, -1, and 9, -1, kind of going off the grid a little there. And then I just know I need to have this general shape. It doesn't have to be perfect, but it's going to curve a bit, and then I'm going to go straight up. Now this, remember, it's vertically compressed, so it's like squishing, and then it's all shifted over to the right 3 places. So that would be it for that one. So I hope that helps you get the idea of how to do a combination one. And again, these are separated off. I had an X thing and a Y thing, but just generally think multiply before you add, especially if it's, you have the Y's have a compress and a shift in the y, you would have to deal with the multiplying first. So that's it for number 2. Again, let me know if you need more info. This one, someone had asked about earlier in the Zoom session, so I'll just go over it briefly. We have this graph, get rid of this here, and we have A, we're looking at when we go ahead and see that we have a coefficient on the x and the input there, we need to factor that out. So make sure you do that. You just have to think about like what times 2 is going to give me the 8 here. So I pull out the 2 times quantity x plus 4 and then just carry out my plus 1. So for this one, I'm going to have a horizontal, let me write that in a different color. So we have horizontal, it'd be compressed by a half. So remember, we want 1 over b. And then I also have a horizontal shift left 4. And I also have a vertical shift up 1. Okay. So in order to perform that here, you could use a different piece of graph paper if that was helpful to you. But we're going to look at I'll do it right on here. I'm just kind of extending out my grid a little bit if I need that. So we're going to multiply all our x values by a half and then add or subtract 4. So we're going to multiply by a half, multiply x's by 1/2, and then we're going to sub 4 from x's, and then we're going to add 1 to y's. Okay, so again, you can just pick out some key points here to work from. Let me get rid of this here. It's for a different part. So we have the x and the y, and I'm just going to pick a few values here. I have a 0, 0. I have a half 1. I have 1.5, -1. And then I also have 2 and 0. And you'll get the pattern after a bit, but I'm going to go ahead and perform these operations here. I'll just do the first one to start with. It's a different color there. So for my x's, I'm going to multiply by a half. 0 by a half is just 0, and then subtract 4, so I end up with -4. If I have a half and I multiply by a half, I'm going to get 1/4, and then I'm going to subtract 4, so that's going to give me 3 and or -3 and 3/4. Okay, so now going along this line, I filled out my x values here and my y values. I just had to add 1 to all of those, and I'm going to go ahead and plot them. So I have -4, 1, which goes about here. I'm going to kind of squish it over. And then we have -3 and 3/4, 2. See how that point over here now is way up there. It's squishing horizontally, but shifting up. But it also, we had that far shift left. of 4. So that's really bringing me over to that far left. And then I just continue along that line where I have -3 and a quarter is at 0, and then I have -3 at 1, and my shape would be like this. Okay, so that's my squish, and then shift and rise up. Another one on this that people had questions about was just the draw in, I'm going to get rid of this, draw an even function that's identical to the M, this, shape here, on 0 less than or equal to x less than or equal to 2. So it's just saying along that same, this piece here, and I want to find its counterpart for even, which is reflecting over the y-axis. So I could just take these points and just kind of mirror them, like looking at this as like a fold in the paper or a mirror, and just kind of do it quickly. But I also want to show you here how I would do that out algebraically, because remember, we have, if AB is on the main graph here, negative AB is on the reflection there. Okay, that needs to come down a little more. So I would have the point, if I have 1, 0, then I have -1, 0. If I have half 1 on the graph, right, then, oops, this should be down here, -1, 0. And if I have, for this case, I have half 1, then I have -1. So that's that. And then this bottom piece too, you could continue along and just do this shape, or you could look at it more algebraically. And so it's just the mirror image reflecting over the y-axis. Same idea here that with the odd, but you are going to have it reflect over the origin in that case. And we did do more work with that on symmetry as well. One other question I had also was, how do you figure this out, like draw a function that's symmetric about x equals 2? Well, you would just draw a line of symmetry here at x equals 2, get rid of this stuff, and then you're going to figure out the mirror image on the other side. So again, it's very similar. You can just kind of grab your key points and go like that. It doesn't have to be real specific and, perfect. You just, I want to see it in your own writing and not computer generated though. So I actually do want to go back over this one for 3e for the odd function, just to make sure you're all set with that. So an odd function means that f of -x equals -f of x. So the way to just put that in easier to think about terms is if AB is on the graph, okay, is on graph, then for an odd function, it would be also minus a minus b would also be on the graph. Okay, so in other words, we're just gonna go ahead and add some points here. So if I have, let's pick some that aren't 0, but I would have -1/2, or 1/2, 1 is on the main graph here. Then I would also have -1/2, -1 would be on the odd So I can go ahead and plot that. So I have this point here, 1/2, or 1, its reflection over the origin would be -1/2, -1 down here. I'll do that in a different color. Okay, so that's what I mean by reflecting over the origin. We also have a 0. Again, we would have -1, and then that would be 0. So that would be this point here is now gonna, for the odd, to add on to this to make an odd function, I would have -1, 0. Okay, and so on and so forth. So that's how that would play out for the odd, and I would end up with just this shape. Okay. Number 4 was a popular one for questions too. So the one that we went over was B, but I can do some others. But again, you want to look at what your transformations are. This is just any point. This 3, -1 is a point on some random curve. I don't know what all the other points are. It doesn't matter. I don't know what the equation actually is. It doesn't matter. I don't know what f of x looks like algebraically. But what I do know is I have this one point, and then I'm going to perform these transformations. So I have a vertical shift, or vertical stretch by 2. I do also have a shift up 4. So I do want to make sure that I am doing my multiplication of 2 first to the y. So I'm going to look at this -1. When I multiply it by 2, I get -2, and then I'm going to add 4, and I get +2. The 3 for the x value doesn't change. So I end up with 3, 2. I'll do another one that's similar to that one. I'll do C over here. You might have already seen D, but I'll work through that one with you also. It's very much the same. So we have a vertical stretch by 2. I have a vertical shift up 1. So that's what's going to happen to all my y values, and then I'll deal with the x. So I have -2 times 2, so that's going to be -4. And then I'm going to shift up 1, so that becomes -3. Now for my x value, that is a horizontal shift right 4. So that, remember, I'm going to do the inverse thing in there. So I'm going to add 4 to my x's. Okay, so I just do that once, so I can just kind of jump all the way down here. So I'm going to add 4. And I'm going to get 7. Okay, so my point that I would write, that I end up with, that would just be my answer right there. Again, here for D, I'll do this one out with you if you want to pause and try it. So we have a vertical compress, actually, on that one. And you can abbreviate when you do these two by 1/2. And I also have a vertical shift up 3, and I have a horizontal shift right 3. So those are pretty similar. So I'm going to start with my compress, just because I want to make sure, I think multiply first. So 4 multiplied by 1/2 would be 2. And then I'm going to add 3, so that's going to give me 5 here for my y value. And then my x, I'm just adding 3, so that's going to bring me to 1. And then my point would be 1, 5. So this is how I just want you to show your work. Just like that is good. Now I do know I had some questions on E and F, so I'll go through those. So I have the 0.39, where does that end up? So I have a vertical compress by a third, but in here I have to be careful. So this input actually I have to rewrite as 1/2. So this is really f of 1/2 x plus 10 there. Okay, so that is going to give me a horizontal stretch by 2. And I also have a horizontal shift left of 10. Okay, so you can see where your shift would end up incorrect if you didn't factor out that coefficient of x in the input. And then we don't have any other y things going on. So I'm going to take care of my y value here. I'm just going to that one in red. I'm going to multiply by a third, so that gives me 3. And then with the horizontal, I have a lot more going on, so I've got to stretch it, so that's going to be 6. So I multiply by 2, and then I'm going to shift left, so I'm subtracting 10. So that's going to give me a -4. So my point is -4, 3 for my answer. So remember, you got to do the inverse thing on each of the x values or it won't come out right. And you also have to factor out that 1/2 anytime there's a coefficient. And then we have f over here. I have the point -2, 1. Where does that end up? I have the vertical. Well, I actually have a reflect. So if I were to write this all out, I have a reflect on the y. So that means it's going to reflect over the x-axis. Right, so every y is going to become negative. So you could think of it that way. You could say multiply y's by -1. I kind of think of it too that, cover up my zoom button there. I think of it just as rolling it together. So I also have a vertical stretch by 3, where I'm going to multiply all the y's by, or multiply y's by 3. So I can do that all in one time together. So I would just, for that first thing, I would do 1 times -3. And then I also have a vertical shift down 5. So now I'm going to subtract 5, so that would bring me to -8. Now on the x side, for the input, again, I want to do the inverse thing. So that's going to be a horizontal compress. So it's always 1 over b, whatever the coefficient of x is, by 1/2. So I take that -2, multiply it by 1/2, and I'm going to get -1. So then my point is -1, -8 is where that would end up if I were like plotting the new point on a graph after performing those transformations. So I think I've done a lot of part 5 as I went through and wrote out things for number 4 and some other things above as I actually did the computations as well in the transformation. So on 5, I'm just going to do D here. And again, you want to make sure if you have a coefficient on that x, you need to rewrite it. So this would become y equals 2f of 3 quantity x plus 2/3. So you're just dividing in. So just make sure, double check that 3 times 2/3 would in fact give me the 2 back. And then I can write my transformations. My first thing I would do is vertical stretch by 2. Then I would do horizontal compress by a factor of 1/3, because remember it's always the inverse. And then 3 would be horizontal shift left 2/3. Okay, and that's all there is to it. Just make sure you number them and have them in order, especially for a test. And you'll probably see something like that on the final, for the paper final. I'll try to give you some more paper practice as we go. Some of your tests are electronic, and you might have to just, pick from a drop-down menu the order. All right, thanks for watching. Let me know if you have any other questions. Have a great day.